Welcome you all to the channel One Stop for Python. And this is the first video in the daily Leetcode series. Uh, the very basic motive behind starting this series is that people are not that friendly while writing code in Python. Therefore, this video is for newbies and also for the mid-level programmers who try to write code in Python, but they are good at logic building. They can write code in C++, but they are not able to think the data structure and how to loop and iterate in Python. Therefore, this is the series dedicated for them. They can build problem-solving skills in Python by solving daily lead code problems with that intention. This is the first video of the series because what I have seen, and that is the very basic intention behind starting this channel, is that a lot of resources out there on YouTube. They all are tailing approaches in C++, some tailing approaches in Java. Therefore, people felt out and follow everything in C++ and Java. But we are here to start the community building in the case of Python. Therefore, I am here love to tell my approaches and how to solve problem in Python and which data structures should be used perfectly. This is the first problem. Problem number is 1061. Problem name is lexicographically smallest equivalent string. Let us jump into the problem and understand the problem statement first of all. You are given two strings of the same length S1 and S2 and there is a string base str. Therefore, what are the pieces of information that need to take into account? First one is that the two strings are of same length. Second piece of information is that you need to tell establish relation between each character S1I and S2I. Relation between each character. Okay. Now there are three relations given: reflexive relation, symmetric relation, and transitive relation. You all know about this relation. There is nothing new to tell you about this. And now let's start understanding the problem that what we need to do here. We have given first string ABC. We have given second string CDE. We are telling that we need to establish relation between each character of both the string. Let's start like first character of string 1 is A, second first character of string 2 is C. We have established a relation, a symmetric relation. See, when we are writing AC, we need to automatically understand that there is a C and A automatically. Vice versa relation is established. Then we need to establish a relation between B and D. There is a relation D and B due to symmetric property. And at last, there is relation between C and E. What you need to observe between AC and CE that this is following the transitive property. Therefore, you need to put E in the first set. Now, we have two sets of characters. This is the set 1. This is the set 2. Now, in problem, we have given a base string. Now, we need to iterate over this base string and we need to return and we need to check like the first character is E. We need to check this, we need to check upon which set this is belonging. Like E is belong to first set and what is the least character of this set? This is A. Now the second character is E. Again, the least character is A. Now the last character is D. Therefore, least character is D. Therefore, what is the lexicographically smallest string possible of the base string EED? It is AAD. Sorry. This B. AAB is the lexicographically smallest string. Therefore, now how we need to approach this problem? We understand the problem statement perfectly. Therefore, the very first thing, how to think in that direction. See, in the problem, the two strings are of the same length. Okay. Now, whenever in the problems are such like the problems like the arrays and the strings, the elements are of same length. Okay, and you need to establish relation between each and individual elements of that uh, array or strings. You need to think in the way of that each element is a node, and you need to when you are establishing relation between two node, and you are thinking in the direction of trees or graphs. Okay, because and how this is beneficial here, because whenever you need to think that there is a node and there are certain conditions given in the question upon which you can interchange the node, or like there is a earlier there is a relation between a and c, now at the last there is a relation between c and e, and you need to change node to the earlier established edges a b a c. Okay, whenever such type of question you need to think in the form of the graph and trees. You need to solve the problem in the form of arrays and the graphs on arrays and strings only, but you need to think in the way of the graph and trees. Now let's visualize the problem very well, and you can understand that how we are approaching this problem. See, we have first string Parker and we have another string Morris, and best string given is parser. What I am telling you, that you need to consider each character as a node. P M A O R K E R, and you need to establish, since each character there the length of the characters are same, therefore you can establish relation between each character. See, when I'm establishing character between P M A O R R R R, see R R here you can say it is a reflexive relation. Here we can here we can this is the reflexive relation in R R. In case of R, it is a reflexive relation. Uh, Now we need to establish between K, R, E, F, R, S. And now how we can think, then what we need to do? We are taking each node. Okay. We are taking each node. We are establishing relation like P, M, A, O, R. Uh, Here we are taking a relation between K, R. Here we are taking a relation between E, I. Here we are taking a relation between R and S. Okay. Again, you need to follow the same property. Like this is a simple symmetric property. This is again the simple symmetric property. This is the reflexive one. You need to check the transitive one. And the best way to think in the problem, the graph, that there's a transitive relation and you need to overlap the node whenever there's a transitive relation. Like here, we have a relation between K and R and S. Therefore, what we have to do, we need to put S here and we need to shift this edge here, and we need to establish relation like this. Okay. Now this is now the problem becomes simple. Now it becomes a graph problem. You can think in the direction of DFS. But what I am suggesting, that what we are doing and upon, because everything you need in the lead code there is a pattern. Lead code medium is just a very, in every data structures, advanced concepts of the data structures. They are taking their advanced concepts and they are implementing simple problems based on that. There is nothing big deal in that. Therefore, you need to observe the pattern. Like here, what we have to do, we just need to return upon each relation, we need to return the smallest, or we can say the leader of each set. Earlier, we have the each node individually. Each node individually, it means each have their own disjoint set. Then we are making union by creating an edge between two nodes. Okay, listen very carefully how we are going in that direction. Earlier, there is all single nodes. Then we are creating edges between them. It is like we are creating union of the disjoint sets they are earlier we have provided. Okay, and each time we need to find out the leader of that set. Therefore, while making the union, we need to test our logic in such a way that each time when we are returning the leader, it will be the smallest character. Like when I am making union between P and M, I will keep sure that here will be M, leader will be M, the child will be P. A O R K R S E I. Okay. Now let's start for writing the output for the parser. Let's take P. The leader is M. The leader is M. And for A, the leader is A. For R, the leader is R. No, for R, the leader is K. Okay, you need to remove this also. And for S, the leader again is K. For E, the leader is E. And again for R, the leader is K. Therefore, output is cake. You understand? This is the very basic implementation of the disjoint set and union find of the disjoint set. Union find is a very basic algorithm that we are used to find this cycle in a undirected graph. And there are very famous use cases of the union find. And whenever you are thinking in the direction of the lexicographically smaller string of the similar length, you need to once think in the direction of the union find. If you want to check out the detailed explanation and how to approach union and find in Python, you check the link in description, or I will also attach that video at the end of this video, so that you can find all the details about the union and find. Uh, in first video we talk about union find, its basic implementation, 2 and 3 problems of the lead code itself. And in the next video we'll talk about the optimization, the rank optimization upon the union and find, and we will do 2 and 3 problem on that also. Okay. Now let's implement this problem. What you have understood that we need to implement, we need to return the lexicographical, or return the smallest character of each set that is made after the union. Okay. Therefore, thinking now the implementers of the union find is out of the scope of this video. Therefore, I am refraining from explaining a lot of things because unnecessarily the video length will be high. Now let's start solving the problem. First of all, we are taking well as A B C D E F G H I J K L M N O P Q P Q R S T U V W X Y Z. Why I'm taking this? We are trying to create a dictionary where we need to create a disjoint set of each individual character. We are trying. This is the very replica of the very first logic implementation of the disjoint set that we have provided with the disjoint. Like we have provided with the disjoint set, and you need to establish union upon finding a age between two individual characters. Okay. Now, how we are establishing the relation? There is 26 characters, and we need to maintain the 26 disjoint set. How we are doing? Let's check it out. We are making a dictionary, and we are using the dictionary comprehension. Uh, there is a very cool concept in Python. See, very small line, very small line. This is a very cool way of doing it. In C++ or Java, you need to write a lot of code. Now, what will be the our what is the our output? We have like this. We have a this will be our output like this. B is to B. Has that up to Z we have in our dictionary. Now, what I am doing, I am trying to make a relation between, like I am taking one character from string one character from string two, and try to make a union between that. How I am doing it? Let's check it out. Therefore, let's see again. You need to think very simply in Python. Like whenever you have two string, whenever you are having two string, like here we have one is ABC, again is CDE, and you need to establish relation between AC, BD, C. A very common thing that you need to come in your mind, that is J function. Like for we need to zip both string 1 and string 2. Now again there is a very cool concept in Python that you can extract item, you can say unpack the zip itself in the for loop. Like this is the first character A, the second character B in the zip. S1 and S2. What is A and B? Like when we zipped A and C, it is like it become a zip object and it's like a collection of tuples. Therefore, A and C, A and B here is the A and C. They are the first and second characters of that tuple. Okay. Now, what we need to do, we need to implement a find function. And what is find, what is union, that you must refer to my union find video. You can understand there very clearly. Now, for finding the leader of that character, we need to implement the find function. Let's understand that first leader is L1, second leader is L2. Again, we are using the cool concept of Python's find of A, comma, find of B. Let's define the find function inside here. See, again, that is a very cool concept of Python that you can do nested functional programming inside a function also. In other languages, you cannot write that. And why we are writing it? What are the code structure? If you want to learn a lot about it, you can refer to my earlier videos where I have in detail about the intricacies about each data structures, about each uh, iteration method, how to master iteration in Python, how to approach, how to choose the data structures in Python. I have make a comprehensive video in that. Check it out. Link is given in the description below. We are implementing the find function. Let's take we need to find x. Now we need to look. We are maintaining the leader of each character in the dictionary itself. Therefore, we are using dictionary. In find union, we are using parent. You all have to remember that thing. You all are remembering that we are using the parent for finding the which one is the leader in that array. Therefore, here we are using the dictionary, that each character in the value of each character which are used as a key, we are storing the leader in correspond to that character. If find x, if dic of x is equal to x, we need to return x. Else, we need to return the find of x. That's simple. This is our find function. Now it becomes L1 and L2 is clear. Now you need to check. Here only you need to check the condition of the union. We are not writing union separately because it is a very simple use case of the find union. You need we not make the code necessarily hectic. A lot of in lot of solution you will find that people will follow the approach of find, right, the class find union. They have a dedicated find function, dedicated union function. But you need to think that like world is like in code. Do not in what is the concept in the coding? Do not repeat yourself. This is a dry principle. And the reusability is the very basic function. That there is a find function, there is union function, there is a there's a class of the find union. How you are using it here and there, they are just like collection of individual concepts, and it together they make a big concept. But you need to go from bottom up approach. Like you are understanding its concepts, then you are understanding the bigger picture. Then you can what is the very basic benefit of this, that you can apply each individual concept, the smaller concepts here and there. Okay. Now what we are doing, we are checking the L1 and L2. If L1 is greater than L2, it means that L2 will be the leader of L1. Therefore, in dictionary of L2 we are storing L1. Okay. Dictionary of L1 we are storing L2. Because L1 is bigger, L2 is smaller, we need to return this smallest lexicographically. Therefore, we are writing like that. Okay, and we need to store dec of L2 is equal to L1. Now our work is over. Now I just need to return this string. Now our now our dictionary contains leader correspond to the each individual keys. Now we are iterate over the base string and find the leader of each character of the base string from our dictionary. And how I will convert that list into a string, that is another thing. Let's take it into the list. We are again using the list comprehension. If you want to know a lot about list comprehensions or problems in the list comprehension, check my earlier videos. Find of I, find of dec of I for I in base str. We iterate over the base str. For each character, we find the characters corresponding to the dictionary. These are the leaders of the dictionary. And how we are finding it? Okay. Okay. And we need to join it. Okay. Uh, this will be the very basic code structure that will be going to happen. Let's run it. Yes, all test cases are passed. Let's submit it. Yes, we have submitted our code perfectly fine, and this is the solution. And I hope you all like this video. I know this is the first video. There's some problem while recording it. After 2 and 3 videos, the videos are going to be smooth, and the problems and the explanation tendency also going to be very far better than this, because this is the first time I am shooting videos. I'm not expert in it, but I am trying my best to tell whatever thing. That was I see smaller videos, because if I can sort also explain this video in 10 to 20 minutes, but that is not a case here, because I am trying to explain you the things how to approach problems in Python. See, I'm telling you about the jig function, how you can unpack individually at the for loop only. How you can see what we have done here. We are using the join function because we are storing the leaders correspond to the each character of the base string in a list. And now it's what is like this. We are like if our base string is parser. We have macaque in our list here. M A K K E K. We have stored like this. We need to convert that list into a string. We are using the join function to a empty string, and that we need to return. This is a very simple thing. Now, please, I recommend you to watch my video on the disjoint set and union. I have very comprehensively taken that class, and you can get all the all the doubt clarified after understanding the disjoint set union, and you can apply it in competitive programming also. You can use that concept to solve the problem here also. In the Leetcode problems, Leetcode medium problem can be solved very informally. You can also use union and find to solve the various graph traversal problems also. You can use in the behalf of the DFS. I have used one graph problem on the basis of that also. Therefore, please check it out that video. And after understanding that video, and after when you watch the video of very basic Python data structures, when you see this solution, see this video, you can get everything very clearly. Okay. Thank you for now. A very good day. Thank you, all of you.